Oh, this is so crazy. So Super Metroid is like always it's almost always a game that's speedrun on these events because it's like so speedrunnable. I don't know if you ever watched the speedrun of Super Metroid or played it. Have you? Well, anyway, they try to mix it up every time. So this time they're doing a two-player, one-controller speedrun. Yeah, and I'm watching the beginning, and so far it's okay. The first few seconds are okay. It's so funny because one side of the controller is used to press jump, and the other side, you know,
Oh, well then that's pretty cool though. Yo, why is this not
oh
working?
my god, they can't wall jump. I don't think they can wall jump.
Oh, interesting.
This is gonna be funny as fuck.
Oh, interesting. Oh, interesting.
This is gonna...
Where's my goddamn fucking link?
So it's funny because they have three cameras on the speed one. One is showing the game, one is showing the players, and one is zeroed in on the players' hands.
Oh, here we go.
They have such a hard time.
Here we go. Bam! Finally.
What are you doing?
I'm sending you a link so that you could take a look.
Oh, alright, I guess I'll watch this later.
I mean, I would just do it through a Google Hangout, or if I could do it through Skype. Is it possible to do something like this through Skype, like a video share?
Hmm.
I know you could do it with Google.
Opened up the thing.
It's done with Google Hangout. Okay, let me show you. I don't know, probably a bigger one. Advanced.
Game is played on a rectangular grid with a given size. Some cells contain nodes with a number on them from 1 to 8. So this number represents the amount of links that the node should... What the fuck? What's with this art from like the Matrix or something?
Oh, like all the things are kind of, they have a theme. This one is Matrix. There was another.
It is Matrix. Ah, yeah.
Yeah. How'd you know?
Well, I recognize the bots from the movie.
APUs.
Yeah.
Okay.
Served with neighboring nodes. The rest of the cells are empty. It's kind of like Minesweeper. Hey, go
like
back up.
your what?
Go back up.
No, there's a delay on it. That's why I don't know how far along you are.
Oh. Okay. This number represents... Okay. The goal is to connect all of the nodes by printing a list of links.
Yeah. They must begin and end at distinct nodes. They must be either horizontal or vertical. They must not cross any other links or nodes. At most, 2 links connect a pair of nodes. The number of links connected to each node must match the number on that node. The links must connect all the nodes into a single connected group. Okay, so what you see here, whenever it pops up my mouse thing, that's essentially what I got to do. I've got to connect all of these fucking shits. So first of all, I need like some kind of function to choose a starting point. Now what I do for a starting point is I decide to go with whatever link doesn't have any extra paths. Like if you look at the 1 on the left side, the only thing that it can connect to is the 3 in the top left corner. So I would start there.
Yes.
And then I would ideally try to make a chain from there
But you'd want to make a program that works for any kind of grid.
Yeah,
Like you don't know what it'll look like.
exactly.
Okay.
So
That sounds hard.
yeah,
Interesting problem though.
its difficulty is hard. Like the puzzles are broken down into easy, medium, hard, very hard. This one is hard.
So maybe before you program it, you have to figure out an algorithm.
Well, I mean, at one point I decided to just take all of the givens, and what I mean by givens is if there's a node with 4 available bonds and it only has 2 possible paths, I would connect both paths with 2 bonds. Same thing if it's 6 possible bonds and 3 paths. Essentially would do that for all of them as a first run, but then I can't keep track of how everything is connected.
Yeah, so I mean that's probably a bad way then to do it. Is to start looking at special cases, take care of them, and then proceed. That's probably a very bad way to do it.
Yeah, and
you can also say something like, "Oh, well, if it's an odd node, at some point it will have to have a one-line connection to another odd node."
Will it?
So
I think it might.
Have to. Nah, never mind. That's not even true necessarily. So.
Yeah, essentially what the whole entire goal of my thing was, the whole entire idea is getting a starting point. So let's pretend like the starting point is something that has only one node. And like the majority of them have a singular thing that you could start with, that you could easily pick out. Then from there, I would use that backtracking algorithm to essentially go through every path, but that's so fucking difficult. I don't understand it so well.
Yeah, if you start checking every possible path, your runtime is going to become so high. It's really inefficient.
Yeah, I know, but
I don't know how to do this. I have to think about it. It's an interesting problem. Maybe I'll talk about it with someone.
And this one is only the advanced one. So essentially you want one program that will do all of these test cases. So there's 13 of them. Obviously simplest ones are the easy. But then you also got the expert one, which is just completely fucking fucked. It's hold up. Yeah. Do you see the expert one?
I paused it to look at the advanced one. Okay, I see system failure. And
yep.
Oh my god. It's huge.
Yeah, it's fun. So this particular...
You might try starting with like kind of a greedy algorithm by looking at the biggest nodes. And
yeah, I was thinking something like greedy algorithm.
So but if you have like any 8 nodes, those are solved instantly. 7 nodes, you can do most of the 7 node, right?
Yeah, but that's also what I did before.
That didn't work. Yeah.
And what I did before, it didn't end up really working all that well.
Yeah.
Like I have programs that work for 47% of the tests, and then the more that I've worked on the programs, the less percent of the tests that they actually pass. Yeah, so the 3 ideas for this particular puzzle, though, it's brute forcing, backtracking, and pruning. Now, I'm not entirely sure of all of them, but brute forcing is basically try everything. Backtracking is kind of like try everything, but move backwards while you do it. So if it doesn't work, you try a different thing. as you go along. And then pruning, I'm guessing, is get rid of possible connections. Yeah, so this is what I've been doing for fucking days now.
Yeah, it's not easy, right?
We've got 391 lines of code, and it's not even fucking
So
doing shit.
So here's the thing you could do. Maybe pruning is not a bad way to start it, but
I'm not entirely sure what.
If you have any nodes of size 2n and they only have n neighbors, right? That's instantly solved.
Oh yeah. Yeah, but then the whole entire problem with that is I can make those, but keeping track of the actual chain, because it has to be connected. It all has to be one continuous link.
Oh God.
So that's the hard part. Like I said, I tried doing the whole entire thing with the givens. I mean, you can do a lot of them with the givens.
Yeah.
Like
here's the thing. If it were me, I would just not do this and just something else.
Just not do it?
Yep, I would just do something else instead.
I mean, there are other ones, but at some point I'm gonna have to learn how to do this.
Why?
Huh?
Why?
Because I feel like knowing how to do this is just good in general.
Like me, I would prefer to just like watch a movie.
Oh well, yeah. I mean, I could do that. So you got this. This is the one you see: backtracking, brute forcing, and pruning. The best I did was 47%. That's not even the hardest one.
Keep trying.
Huh?
Yeah. So, what do you want to do now? You want to keep doing it?
No, I'm probably done for now. Oh, hold on. This has to do with maths.
What?
I've never looked at this one.
Oh, should I go back to the stream?
Meh, never mind.
I'm watching it. Roller coaster. What's this? You have been recently assigned to a new amusement park center. Yeah, you scrolled. Okay. Analysis and paused it. Supervision. Your mission is to estimate each day what the earnings will be. I don't know. I don't really feel like doing that.
Reading it?
Yeah. No, I mean, staying with a bunch of roles, I'm like, okay, well, yeah.
I mean, it has to do with math.
They all do.
No, but this is particularly, like, with math. Let's see what happens here.
People queue up in front of a attraction. They can't be alone. They can either be alone or in a group. When groups are in the queue, they necessarily want to ride together without being separated. People never overtake each other. When there isn't enough space, the ride starts. It's not always full. As soon as the ride is finished, the group moves up, back to the queue in the same order.
Oh, yeah.
The attraction contains a limited number of places. The attraction can only function a number of times per day. The queue contains a number n of groups. Each group contains a piece of 5 people. Each person spends 1 dirham per ride. Where the fuck are we? Fucking Kazakhstan?
Oh, well, it's a French website.
Oh.
Each group contains 5 people.
So with like 3 sizes. That's it? That's the whole thing?
What?
I like the question, it's not doesn't seem that hard. You have a variable to increment the number of rides, and then you have a variable that keeps track of the number of people in a ride, and then you just translate a vector. This is really stupid. It's easy as fuck. I could probably program this in 15 minutes.
Well, I mean, for some people it's easy. For other people it might not be easy.
I mean, am I missing something? Is it not easy?
I don't know. I didn't read it. I don't understand it.
What?
I didn't really read it. I was just hoping you would give me the answer because you're so smart and shit. Okay, hold up. Let's see what the values are with L. L is number of places. C is number of times per day. N is number of groups. Well, we know that N is equal to 4 in this case. Yeah, so 3, 3. So the traction contains... Wait, what are you supposed to do exactly? Oh, okay, so there's only 3 possible things. Functions 3 times a day. Yeah, so this is probably fairly easy.
It's fucking easy.
But
Teeth really hurt.
so then you get like 1,000 groups where you have...
Who cares? You just put a loop in.
I know, but
It's like really easy.
I think this one might be about optimization and stuff. How many? Oh, look at all those groups. Those are large groups. Wow. Wow, that's a lot of... Wow.
Hold on, let me go live.
Those are big numbers.
Where? Yeah. That's a lot of people in a group, huh?
Yeah, and there's a lot of groups. See
Okay.
that?
I mean, it doesn't matter.
See how I'm scrolling? Well, actually it does, because you gotta optimize it in a way so that the program doesn't time out.
Time out. It's really simple, right? Like
What's the output that they want?
they want the money, or really the amount of people that rode the ride.
Oh, so there's... Oh, okay, so just print the answer. Okay.
Anyway, you want to play something?
Oh, I guess I would just use module and stuff like that. There's a lot of things that I was supposed to do.
Mm-hmm.